What's up guys, if you hate JavaScript, this is the video for you. We're implementing Conway's Game of Life using only CSS. You can see some examples in the background, and of course this isn't just a CSS animation, but the actual logic is being performed using only CSS. First, let's add our HTML, a container, a grid, and 36 cells. We center our container, add 6 columns to our grid, and style our cells. Next, we initialize our board. We add 36 properties to our root element. Each represents the initial state of a cell, 0 being a dead cell and 1 being a live cell. To change the color of our cells, we change the contrast of each cell based on the property. We could copy-paste this code block in order to apply the contrast filter to each cell, but instead I decided to just use a Sass loop. Adjusting the properties in our root now lets us have any initial game state. Next, we have to start building our game logic. Each iteration, 4 rules are applied to each cell. A live cell dies if it has fewer than 2 live neighbors. A live cell with 2 or 3 live neighbors lives on to the next generation. A live cell with more than 3 live neighbors dies. A dead cell will be brought back to life if it has exactly 3 live neighbors. To implement these rules, we first have to calculate the number of neighbors each cell has. This is done easily by adding the values of all its neighboring cells. We will save this value as a custom property. We can generalize this for every cell using a Sass loop by calculating the mod of the number of cells our board wraps around the edges. We will now implement the 4 game rules to Conway's Game of Life. Initially, we will do this for 1 cell for 1 iteration, and later we will generalize to apply our rules to all cells over multiple iterations. The first rule we will implement is Rule 3. A cell with more than 3 alive neighbors dies. With CSS, we can calculate 4 minus our variable for the number of alive neighbors. This gives us 0 or a negative number if the cell has 3 or more alive neighbors, and a positive number if it has 3 or less alive neighbors. By taking the max of this and 0, more than 3 will be 0 if Rule 3 applies, and a positive number if it doesn't. Our remaining 3 rules all deal with cells with 3 or less alive neighbors. We can rewrite these as: a cell with 1 alive neighbor dies, a cell with 2 alive neighbors keeps its current state, and a cell with 3 alive neighbors turns alive. We can cover all 3 of these rules with this CSS. We take our variable for the number of alive neighbors plus the value of our cell, 1 or 0 depending on if it is alive. Then we subtract 2 and take the max of the result in 0. We're going to explain this rule with a few examples in a second, so don't worry if it doesn't make sense right now. To get the final value for a cell, we multiply the result of this rule with our previous rule. We will multiply because both rules need to be fulfilled for a cell to be alive. Then we take the minimum of the result in 1. This turns any positive result we get into a 1, which is important for future iterations. Our full code for calculating the state of cell 14 after 1 iteration now looks like this. We calculate the number of alive neighbors. Then we apply our 2 rules. Then we get our final value by multiplying both of our rules and saving it as a custom property. In this example, cell 14 has 4 alive neighbors. Fewer than 4 therefore calculates 4 minus 0 because our cell is currently dead, minus 2 resulting in 2. More than 3 calculates 4 minus 4 equals 0. By multiplying both values, we get a result of 0 for the first iteration. This satisfies Rule 3 of a cell dying of overpopulation. Let's say cell 14 only had 3 alive neighbors. Fewer than 4 now calculates 3 plus 0 minus 2 equals 1. More than 3 calculates 4 minus 3 equals 1. As a result, we get 1. Our cell turns alive. Note that if our cell was alive to begin with, the only difference would be that fewer than 4 would now calculate 3 plus 1 minus 2 equals 2. Our final result would still be the same, as taking the minimum of 2 and 1 would still result in 1. Either way, Rule 4 of reproduction is satisfied. Feel free to pause here if you want to go through more scenarios. To generalize the code to calculate multiple iterations for each cell, we add 2 Sass loops. The first loop defines the number of iterations. The second loop loops through all the cells. We then calculate the values for each cell and save it as a CSS variable. We could of course write this without Sass, but this file compiles to 5,000 lines of CSS. You might have noticed that we are only calculating 4 generations. This is because our calculations always rely on previous calculations. At step 4, the calculations for the value of one cell is this long. Trying to add another iteration breaks CSS. With that, our logic is done. The only thing left is to add an animation using our calculated values. We loop through all the cells, create a keyframe animation, and change the contrast based on the calculated value. We add the animation to the cell, add a duration, timing function, delay, and have it loop infinitely. And that's it. If you liked the video, you can like and subscribe. Also, there's a link to GitHub where you can find the code. There's also a link to Codepen, but the code isn't working on Codepen.